Okay, good morning, everyone. So, welcome to week 7 of our 10-week course. I'm really excited about this one particularly. We'll talk about queen rearing and queen breeding. It's something I'm really passionate about. It's something I'm really excited to talk about. I'm sure some of you have done queen rearing in the past, and so one thing I'll talk about are different methods to raise queens. There's not one way to do it, and it depends on sort of where your goals are. So, how many queens do you want to raise, per year, and how many colonies are you raising queens for? And so, there's a lot of questions involved with raising queens. And so, I'll talk about different methods, and you can kind of figure out which method works best for you. And some of these can be more trial and error in figuring out what method that you want to use. So let me share my screen. Okay, so today we'll talk about, breeder queens. And so how do you do a trait analysis and how do you choose which colonies you want to graft and select from? Two, we'll talk about the differences between a starter and finisher. And as I'll talk about, the starter colony and the cell builder is probably the most important part of raising queens. And so when you ever begin grafting, whether you decide to do that or not, it's really important to have a really strong cell builder and starter colony to get your cells started, and then finally having a finisher colony to fill the cells so you can raise your queens to the highest quality as possible. We'll talk about different equipment, grafting techniques, and other considerations when you're deciding to raise queens and graft queens. So when you think about raising queens, there's sort of three major steps, right? So first is choosing your breeder queens. And when you're choosing your breeder queens, it really depends on your goals as a beekeeper and why you're raising queens. So for some people, they're just raising queens from their best performing colonies, the ones that overwinter, the ones that produce high amounts of honey, maybe the ones that have lower, varroa infestation levels, so things like that. And so some are just choosing the best performers. So there's not really a wrong way of doing it. And as we get into the second part of this talk about breeding, if you do want to have your own like breeding program, breed for locally adapted stocks, there's some other considerations, but you can pretty much graft from any colony. So if you have one that you really like, one that's less aggressive or whatever you're looking for, these are ones you can choose your breeder queen from. And then we'll talk about cell builders and finishers and the differences between them. And there's definitely a lot of ways to raise queens, right? So you can have a separate cell builder and a separate finisher. And really what that means is you have one strong colony that's using to start the cells. And so as you can see from this picture, you can see that the cells are starting to be built by this small wax capping. So I mean the bees are starting that cell. And once you have that cell started, it's really easy to build that out into a finisher colony. But having a really strong well-formatted cell builder is really important for queen rearing. And then we'll talk about grafting. And so grafting is one of those things where it just comes with experience. It comes with doing a bunch of grafts. And so you might have difficulty doing grafting for the first time, but as you gain more and more experience, you can figure out how to do it in a really quick fashion. And so there's different grafting techniques you can use, different grafting tools, and so we'll talk about those. So first we'll talk about how to choose a breeder colony. Now, a lot of times it kind of depends on how many colonies you have. So if you only have a few colonies, for example, you won't have really a widespread selection criteria, right? So if you have two, you might just be grafting from one to replace the queen from another colony or produce a nook or split that colony. But I mean, let's say you have, 10, 20, hundreds of colonies, you can have kind of a more thorough selection process. So first, I want to talk about some of the breeding lines. And so, what's great about the United States is we have a lot of really well breeding programs, and these breeding programs have really been targeting the varroa mites. So we've had some before the varroa mites were introduced into the United States, and those breeding programs were really targeting American foulbrood, but mostly honey production and colony size. But ever since Varroa was introduced and we started seeing problems with the Varroa destructor, there's been a lot of breeding programs that have been targeting Varroa, but more importantly, selecting for traits that lead to resistance or even tolerance to Varroa and their associated viruses. So one program in North America is a Saskatraz breeding program. It's done by, I'd say, one of the best breeders in the world, Albert Robertson. He's located kind of near Alberta, Canada. And so he's had a breeding program. He started with a bunch of different stocks. So he started with, Poline, Russian, buckfast, and basically selected based on honey production, row resistance, and just resilience, especially in the colder climates of Canada. Now it's really hard to find the pure Saskatchewan stocks just because of the border issues and getting bees from other countries. But there is a major queen producer in California that still grafts and produces Saskatchewan. So you may go to some bee supply store and see Saskatchewan, but just know that this isn't the original stock. It's probably a few generations away from the original breeding stock. The Russian breeding program, so once Varroa were introduced into the United States, it became a really big issue for beekeepers. The USDA facility in Baton Rouge found these bees in Russia. And these Russia had dealt with Varroa mites for a very long time. And because of that, they basically had these traits that allowed them to be resistant or tolerant to Varroa. So more importantly, they had the suppressed mite reproductive trait, which I'll talk about. They had high grooming behavior, so they had a lot of these really great traits for Varroa resistant. And so the USDA brought them to Baton Rouge, started maintaining that line, and then helped the formation of the Russian Queen Breeders Association. And now today, the Russian Queen Breeder Association, they maintain the stock. They have various lines within the Russian stock, and they distribute these to beekeepers across the U.S. And I do know there's a few that maintain it here in Texas, but you want to make sure that they're getting it from the Russian Queen Breeder program because there's some people that market them as Russian, but they're not getting them directly from the Russian Queen Breeder program. We have the mite biters, and so when I was at Purdue University during my PhD, we worked with this mite biter stock. And the goal of this breeding program was to breed for bees that can have intensive grooming, this biting behavior to find the mites and remove the mites. And so starting around, I believe, late 90s, early 1990s to 2001, they started this mite biting breeding program. And what they did was they put sticky boards on the bottom of the colonies. They collected the mites that fell on the sticky boards and measured what proportion had their legs bit off versus ones that didn't. And after I think 4 to 5 years or so, they had a stock that the bees were basically biting the legs off of 50 to 60% of the mites. And so one way we can breed for row resistance is by this mite biting behavior, this intensive grooming behavior. Poline. So Poline was originally selected for VSH, which is row sensitive hygienic behavior, and this VSH trait was selected on Russian. And so the Russians had this really great trait where the bees would actually uncap the cells, find the mites, and disrupt their mite reproduction. And in some cases, actually remove the brood and remove the mites. And so this basically disrupted the whole mite reproductive cycle and caused and led to mite resistance. But the one problem with the VSH slime was it was highly selected for and it wasn't a great honey producer. So what they did was they made it hybridized with more of an Italian honey producer line to make it more pollination friendly and more beekeeper friendly. And so that's why they call it pole line. So pole line is short for pollination or pollinator line because it's a mixture and a hybridization of VSH and a high producing honey yielding stock. Minnesota Hygienic. Minnesota Hygienic isn't a specific line. At the University of Minnesota, they started breeding for Minnesota Hygienic, so they had a line originally, but it's more of a trait-based selection program. So, especially in East Texas and parts of the southern United States, beekeepers are selecting for Minnesota Hygienic. Now, you can select for Minnesota Hygienic from any stock you have. So, if you're a beekeeper and you buy Italian stock, Carniolan, you can breed and select for Minnesota Hygienic, and it's actually relatively easy. And so, something that you can measure for multiple colonies and other stocks. Buckfast was an original stock in Europe by Brother Adam. It was mainly bred for high honey productions and resilience, and so it was a really great stock. But like I mentioned with Saskatraz, they started adding on row resistant traits to it. And then we have Hilo. Hilo breeding program is, well, so with the pole line breeding program, this was started at the USDA Bee Lab in Baton Rouge. And the problem with the USDA facility is they don't have capacity to raise large amounts of queen. And so one thing they did was they teamed up with a commercial beekeeper in Hilo, Hawaii. They teamed up with Project Apis mellifera, which is a nonprofit organization that really supports the beekeeping industry, to find ways to get this pole line stocks into the hands of beekeepers across the U.S. So they brought Poleline to Hilo, and they basically made hybrids of Poleline with Italian stocks from California and produces Hilo stock. And so Hilo has some of these pole line genetics, including the VSH, but also has high honey production and more, I guess, better for the commercial industry. So these are the different breeding lines. There's definitely a lot of beekeepers that have their own breeding lines. And so even in Texas, beekeepers have their own breeding lines, whether they're selecting and breeding from survivor stocks, whether, like the Weavers, for example, they have their own breeding program. And so these are just a few of them, but there's a lot of really great breeding programs across the United States. And there could be potential for you as a beekeeper if you do want to get into queen rearing and eventually breeding to have your own stock. So as a beekeeper, it's really important to understand and really identify which traits you want as a beekeeper. So, for me, and as we start our breeding program at Overton in the next few months or so, these are things I'm really looking for because these are kind of based on what beekeepers want and what will really help beekeepers produce stronger, healthier, and more resilient bees. So number one is honey production. So, most beekeepers want colonies that produce large amounts of honey. And whether that's for wholesale, whether that's for selling at a farmer's market, they want high honey production colonies. And so that's definitely one trait that a lot of beekeepers are looking for. And one reason that Italian honeybees were first introduced in the United States because they were high honey producers and were really valuable to beekeepers. Especially for beekeepers, we want bees that are just less defensive and less aggressive overall. And so nobody wants to work with bees that are going to pursue you and chase after you. And so definitely as beekeepers, we want bees that are less defensive. And even if you're a beekeeper and you're selling queens and nooks and packages to other beekeepers, especially new beekeepers, you want to have queens that are less aggressive and less defensive because that's something that will be they might not be willing to come back and buy your queens later on. And so something you can add to your selection program or how you choose your grafting colonies is by which ones are less or even more defensive. Row resistance is something that I think all beekeepers should be breeding and selecting for. And so, row is the number one major challenge for beekeepers, but it's also one thing that beekeepers can breed and select for. So, early on, I talked about the five P's, right? We talked about Varroa, pathogens, poor nutrition, pesticides, and poor queens. Now, a lot of these things are out of the control of beekeepers, like pesticides, poor nutrition, things like that. But something that beekeeper can do is they can breed for some of these Varroa resistant traits, such as this intensive grooming or mite biting behavior or the suppressed mite reproductive behavior. And we know just from some of these other breeding programs, if you have a really well, high quality breeding program, that you can breed for bees that are resistant and tolerant to the Varroa mites. A colony growth. So this is something that I think a lot of beekeepers look for, especially here in Texas. And so, especially since we have like, 5 winters and we have these kind of warm spells in the middle of winter, you don't want bees that build up really quickly and go through the honey stores. And so one thing you could look for is bees that are more readily going to be able to shut down in the winter, not go through the honey stores, and are better overwintering, especially here in Texas. But you also want bees that are going to grow pretty quickly in the spring so they can take advantage of the pollen sources, the nectar sources, especially here in Texas. And so something you might want to look for is your colony growth and your colony's ability to make it through the winter. And then one thing you can just do is just, raw survival. Which bees are surviving, which bees are resilient, and which bees are seen to be performing better here in your area. So you always talk about these locally adapted stocks, and there's definitely not one bee that's going to perform best in each region, because we do know that bees can be bred for foraging on certain crops and plants, and so you could breed for bees that are locally adapted to West Texas versus East Texas versus South Texas. And one simple way you can measure that is due to just survival. And so these are just a few traits, but there's hundreds of different traits you can look for, and you can measure these traits in a more complex way, or you can measure in a very simple way in sort of a rating system. One thing to always look for is a trait heritability, and the one reason I bring this up is because it's a based on the heritability of the trait, this basically influences how fast you can breed for that trait. And so, for example, if you're breeding for honey production and it has a low heritability, it may take you, 5 years to breed for bees that produce a lot of honey versus maybe 1 year for one of these other different traits. And so, you as a beekeeper want to know like the heritability of each trait and whether that influences your breeding decisions. But it could influence whether how long that trait will be bred and improved. So this heritability ranges from 0 all the way to 1. And like I mentioned a few weeks ago, in the genetics section, a heritability in 1 would be, this would basically mean that the genetics are playing the primary role in the trait. And so if a heritability has 1, like an example, that would be eye color. We know that genetics are playing a really important role in that trait, and the environment doesn't play a huge role. And so if a trait has a high heritability and genetics are playing a really big role, you can graft from that queen, and you know that the genetics will be passed on to future queens and lead to that trait. But if your heritability is really low, like closer to 0, for example, then the environment's playing a big role. And so that means if you're grafting from a breeder queen, that you may have a low chance of those genetics being passed on next generation because the environment's playing a huge role rather than just the genetics. But fortunately for honeybees, most of these traits are really heritable. So one thing we look for are everything above this kind of goldish line, which is a point 0.3. And as you can see, breeding for swarming, breeding for pollen collection, fertility, robbing, honey yield, all the way to propolis, they have extremely high heritabilities. So that means that if you do have a breeding program and you're looking for these traits specifically above this line, that you can basically breed for these traits and have that trait within a few years. But like traits like royal jelly production, varroa defenses, like VSH and grooming, they have a lower heritability. So that means instead of taking maybe 1 year for propolis, it may take 3 to 5 years for varroa. So that means, if you do have a breeding selection program, that it might take a little bit longer. You might not get the results right away. And you just have to be persistent and you need to kind of push through and try to get the traits that you're looking for. So one trait that I guess we're looking for in the Overton facility at Texas A&M is this grooming behavior because one way that we're planning on breeding and targeting mites is by one, having the adult bees find the mites and chew the legs off as they're in the phoretic stage and are on the back of the bees, and then two, basically suppressing the mite reproduction inside the cells. And so we're basically trying to combat mites in two different ways at the phoretic stage, and then at the reproductive stage of the mites. Now, one way we can breed for this intensive grooming is what we like to call, mite biting. I've heard the term mite hunting. Basically, what it means is the bees are finding the mites, they're hypersensitive to it, and they're taking them and chewing their legs off. And here's some pictures of what the mite biting stock at Purdue looks like. As you can see from this picture, you can see, 3 legs chewed off from the mites. This one has two, and sometimes they even kind of bite on the actual chitin of the mites. And so you can actually breed for this. And one thing that I always like to mention is, a lot of beekeepers are collecting, feral stocks either through bee removals. I mean, mostly through bee removals, and these bees are living in the forest or somewhere out in the natural environment. And obviously, they're not being treated or managed by a beekeeper. And one thing we see with a lot of these feral stocks is they have this really intensive grooming behavior. So, one way some of these feral stocks may combat mites and become resistant to mites is one, they're swarming more often, right? So they have these brood breaks, but also they have this more intensive grooming behavior. And one thing we see in the Arnett Forest with Dr. Tom Seeley's studies is one reason those feral stocks are unmanaged but so mite resistant is because they have this intensive grooming behavior. So this is a really hard trade to select for, and it's really time consuming. And that's one reason that a lot of beekeepers aren't selecting and breeding for mite biting. Because one thing you have to do is you have to put a sticky board on the bottom of the colony, and then about 3 to 4 times a year to collect those mites and measure what proportion have their mites chewed off. And it takes a long time, as you can imagine. Mites are really small. You need a specialized mite equipment. It'd be nice to have pictures, like photographs you can take, and potentially maybe an AI system to help us identify this. But currently, where we're at, it's a really hard trait to select for it, even though it would be a really great trait for a breeding program. Two is rose sensitive hygienic behavior. And so this is originally developed in the USDA Bee Lab. And so like I mentioned with the pole line breeding stock, they started with VSH. So that means is when mites are jumping inside the cells and basically feeding on the bees and reproducing, that causes the young developing bees to produce a very specific pheromone. And based on that pheromone, bees are really sensitive to that. They can actually uncap the cells and remove those bees with the mites on it. And so that not only disrupts the reproduction of the mites, but it also allows the bees to remove those mites and push them into the phoretic stage. And so this has been a really valuable trait. And it's not as time consuming as mite biting, but it still is a little bit time consuming because you have to open up about 100 cells. You have to one, see if there's mites inside the cells, but two, see if the mites are sterile or not. So it does require specialized training. But we do know if you're breeding for VSH and viral sensitive hygienic behavior that you can have viral resistance and you won't have to, you won't have to treat for viral mites with this trait. And one thing I've been really excited about, and maybe some of you follow some YouTube channels and follow some beekeepers like Corey Stevens and other beekeepers that are breeding for VSH. They've seen huge success by breeding for this. They've seen huge success in having row resistance, and so there's a lot of potential for breeding for VSH. And one thing I'll note here is that we're developing a genetic test for VSH, and so this is a really time-consuming trait to select for, but one thing we want to do is allow beekeepers to collect maybe 100 worker samples, send them to a lab, and get them sequenced to say, okay, these ones have VSH and these ones don't, to make it easier for a beekeeper. So that'll be available probably next year or so, probably at the end of this year, maybe October, November. So once we have that, we'll keep in touch about that. One trait that became really valuable was what we like to call Minnesota hygienic. It was originally developed by Marla Spivak at the University of Minnesota. She just retired, but she started developing this assay starting in the 1990s. Now, this isn't a row-resistant trait, but it's more of a disease-resistant trait. And so she started working with a lot of beekeepers in East Texas and across the southern United States to begin selecting for this trait. And like I mentioned earlier, you can breed and select for this based on all your colonies. And so if you want to see if your colonies are hygienic or not, this is something that's really easy for most beekeepers to select for. And it's actually really, really fast. So what you do is you freeze 300 cells. Now, typically when I do the testing, I'll get like a PVC pipe that fits over 300 cells. I'll pour liquid nitrogen over that, and that'll kill all the 300 brood. I'll put that frame back into the colony, and then over the next 24 hours, you can see whether the bees are hygienic or not. If the bees are really hygienic, they'll remove most of those dead brood after 24 hours. If they're not, those will be some dead brood still in the colony. Now, this is an example of a non-hygienic colony. So you can see after 24 hours, there's still a lot of cells that haven't been uncapped yet. A lot of dead brood still in the cells. And so this is an example of a colony you probably wouldn't want to breed and select from. But this colony is really hygienic. So you can see that there's a few cells left, but most of the dead brood in the cells have been removed and uncapped. So this colony is really hygienic. Now, why do you want to select for hygienic behavior? It's not necessarily for the row resistance, it's more for the disease resistance. And so, if we select for this, we see less of the chalk brood. We don't see American foul brood really ever since we started selecting for this. And so it's been a really valuable trait. And one reason I think a lot of beekeepers don't see chalk brood or American foul brood anymore because a lot of beekeepers have started selecting for this. And so most colonies in the United States are pretty hygienic. But before we started selecting for this, we saw a lot more chalk brood and a lot more of these diseases. So as a beekeeper, right, there's specific traits you can select for either disease resistance or row resistance. But there are some qualitative traits that you can add to your selection program. And so as I mentioned with our inspection guide, one thing I always recommend is looking at the brood pattern. And so looking at a few frames, measuring the brood pattern, and this can be a really important qualitative trait. It's also a really quick and easy trait to select for. So one thing I do is I rate the brood pattern from a 1 to 5. And so I'll look at maybe 2 to 3 frames, compare the brood pattern, and just give it a simple score. And so this is a really quick and easy way to measure some of these traits. So for example, I'd give this one a brood pattern of a 1. It's very spotty. The queen's missing a lot of spots. And as you can see, even though there's pollen on the outside, a lot of these spots where there's no pollen or nectar are empty. And so to me, this is a sign that this is a poor brood pattern. Whereas this one's very solid. There's not many open spots. And so this is something you can add. But there's definitely a lot of other qualitative traits you can add. And so you can do a ranking system for any trait that you want from a scale from 1 to 5, 1 to 10, depending on your preference. So like honey production, for example, you can physically pull off all the honey and weigh the honey from each colony, but that takes a lot of time and a lot of effort. But one thing you can do is you can rate them from 1 to 5. So maybe this colony produced a lot of honey, so you give that one a 5. And maybe this colony barely produced any honey, so you can give that a 1. And so that's one way to rate it. You can do kind of aggressive defensive behavior. So maybe this colony is really aggressive, so you give this one a 5. And this one's less aggressive, so you give this one a 1. But what's great about these qualitative traits too is you can measure them multiple times throughout the season. So if you're inspecting your colonies, once a month, for example, so maybe you're doing, five or six inspection events throughout the year, you can measure these traits because they're simple and fast, and then do the average across the entire season. And so it allows you to get kind of a more accurate feel for some of these traits. So example, your brew pattern might be really poor during one month, but the rest of the months it's really solid and a really great brew pattern. And so you don't want to base on just one snapshot. You want to try to measure these multiple times if possible. So as we get into the breeding section and as we start developing our breeding initiative for beekeepers across Texas, we'll have a whole list of how you can measure these and the qualitative type traits. But this is a very simple thing that most beekeepers can do. One thing I do recommend is some of these presence and absence traits. So if you're grafting, you want to graft for colonies that don't have any diseases or pathogens. And so, for example, um, like if you have this, for example, this would be, absent of any diseases. So the brood looks really healthy. I don't see any brood diseases, and so seems like a very healthy, strong colony. Whereas this one has the presence of some diseases. So you can see European foul brood, for example. You can see the curled up cells, you can see the scaling at the bottom. And so this would be an example of one that I wouldn't want to graft and breed from. And so, I mean, this could be due to the queen genetics. And so if it is due to the queen genetics, this is one colony you want to graft from. But there are some other presence and absent traits that you can use. So any type of disease can be presence, absence. It can be, aggressor trait, for example. So any type of these presence, absence, and ones you want to automatically throw out. One thing, like I mentioned, is we're developing a genetic test for beekeepers, and so we want to make this as easy and straightforward as possible, but also have more unbiased data on how you choose your grafting colonies. And so one thing we're trying to do is develop a genetic test to predict which colonies have all the traits you want as a beekeeper. And so we'll get into breeding scores and breeding values a bit more in the second section, but one thing we're doing is we have breeding scores for each of these traits. So the higher the breeding score, the higher potential it does have that trait. So example, this one has a breeding score of a 1 for deformed wing virus, whereas the best one had a breeding score of 10. So what this means is this colony is more likely to have deformed wing virus versus other ones. But we look at production, this one has a breeding value of a 10, so this one is more likely to produce more honey, have a greater brew pattern, and higher colony growth. And so you can breed based on very specific traits on these breeding values. But one thing we do is we combine all these numbers into one simple score called the queen score. So the better the queen score, the more likely it is to have all these traits you want as a beekeeper. So if it has a queen score of 10, this would be one you might want to graft from. But if it has a score of a 0 or a negative 10, this might be a colony you don't want to breed and graft from. So this is something we're currently developing, and hopefully we have this readily available soon. Okay, so next we'll get into the queen rearing and the starter and finisher colonies. So, the first step was really identifying your breeder colonies. And, some of you may only have a few colonies. And so you're only basically screening two colonies. And in most cases, you may be grafting from just your strongest colony. But when you're choosing your breeding colonies, maybe you have 10, 50 colonies. So you can do more selection and choosing your breeders across multiple colonies. And so it kind of depends on how many colonies you have and what are your goals. So one thing when you think about queen rearing is it's really important to understand the behavior of bees and why they raise queens. Because if you understand the behavior of bees and why they raise queens, you can really develop your own queen rearing method. Now, there's really two major reasons why a colony will raise a queen. So one is if they're queenless. And so, I mean, most situations, if a colony becomes suddenly queenless, like an emergency situation, the colony becomes really frantic because they want to raise a queen as fast as possible. Because within the colony, the bees know that once a larva get too old, past 3 days old, that colony can never raise queens again. And so they're kind of in this frantic queen rearing mode and raise a lot of queens at one time. So this example of emergency queen cells. And so this queen was accidentally killed, I think during whitewash, or maybe the beekeeper accidentally crushed him. I don't know exactly the history, but the queen died suddenly, probably due to the beekeeper. And I came back probably a week later, and we saw a lot of these emergency queen cells. So we saw about 10 or 15 on the face of the frame. And we also saw a lot of nectar around them because the workers are focusing more on nectar to really support the queens. And so this colony became suddenly queenless. They became really change their behaviors to start raising high amounts of queen at one time. And so a lot of queen rearing methods focus on this queenless behavior and using queenless colonies to produce large amounts of queen. Another one you can utilize is swarming. So when a colony is really strong and the colony is deciding to fly out and form a new home, they start raising new queens. And in my opinion, I think the swarm cells and the swarming behaviors produce the best queens. You know, you have a really strong colony, they have a lot of resources, and they're investing a lot into queens. And so, you know, I've done some comparisons between emergency queen cells or queenless colonies versus swarming, and I think the swarming ones produce the best. Now, that's not always the case, but I always like producing queens in sort of a swarming situation rather than a queenless situation. But there's really not a wrong way of doing it. As long as you know the behaviors of the bees and why they raise queens, you can raise queens a lot of different ways. And as we get to the next slide, and the next different methods for raising queens, you can change your practice. I think there's probably 10 or 15 ways of doing it. I'll kind of outline things that you can do, but this isn't the only way to do it. And I'm sure a lot of you raise queens in a lot of different ways. Okay. So one thing, so let's say you have a few colonies, for example, and or you maybe just want to raise, you know, one or a few queens. One way you can do that is through this Miller queen rearing method. So it's a very simple queen rearing method. So what you do, and this is just kind of a small frame, but let's say you have a larger frame, you can cut wax foundation into these small triangles, and so you expose the outside of it. You can get that drawn out, and you can have the queen lay eggs in this. And once you have that situation, you can put that back into a queenless colony and have them raise queens. I've never done this Miller method because I'm not raising a small amount of queens, but if you only have a few colonies, maybe 5 to 10 colonies, and you just want to raise a few queens, this would be a really great way of doing it. So it's very simple. You basically see young larvae on this cut comb. So you get this drawn out, you have the queen laying on this, and you transfer this into a finisher colony, for example. And what's great about this is there's no grafting involved. The queen's basically laying eggs. And so they're basically putting all the young larvae and eggs into the cells for you. And so if you're not comfortable with grafting, this could be one situation you can use. But you also need a strong colony is required. And so I've never put this into directly into a queenless colony, so you probably have to get these cells started and then put into a queenless colony later once the cells are starting to be fully formed. And once you put them in, what you can do is what I guess what I would do is I'd only allow one cell to emerge. You know, typically one of the queens will emerge early and go back and kill all the queen cells. But you can just basically take off one of these queen cells and put them into a queenless colony if you want. And as you see from the pictures, there's quite a few queen cells on here, and you definitely don't need all of them. So when you think about why colonies raise queens, right, one thing you can look at is that swarming behavior. So, you know, once a colony is preparing to swarm, they raise large amounts of queens on the bottom of the frame, and they typically have a lot of resources and a lot of bees because they're a really strong colony. And so there's active queen rearing mode through the swarming behavior. So one thing I guess I like to do is use this swarm box. I guess some people call it a shaker box. I've always called it swarm boxes. I know there's different types of swarm boxes if you're catching swarm, but I've always called this a swarm box. It's basically a modified Nook box. It has this sliding cover to seal the colony completely because with the swarm box, you don't want any of those bees to be able to move. You want to keep all the bees within the swarm box. And at the bottom, there's this kind of mesh screen around it to keep it well ventilated because you know, one thing I was gonna talk about is you're adding 8 to 10 frames of bees, or about 8 to 10 pounds of bees into this. And so you don't want the colony to overheat in any way possible. So one thing I do recommend is adding as much ventilation as possible, especially keeping all the bees in this enclosed swarm box for 24 hours. So what I typically do is I prepare the swarm box about 1 to 2 days before grafting. So I typically do about 1 day, if possible. So what I typically do is I place sponges on the bottom of the swarm box to have some moisture. I place about 2 to 3 frames of honey and pollen in the swarm boxes so they have some nutrients because remember all the bees are basically in the box, they're unable to move. So you want to make sure you provide them as much nutrients as possible. And then I basically let them sit there you can do this for 2 hours or you can let them sit in this box for 24 hours. I typically recommend maybe 2 to 4 hours, but 1 hour should be more enough where they get into that swarming behavior. Next thing I do is I typically shake about 4 pounds of young bees. Now it's really important to have young nurse bees. If you add older bees and older bees, for example, then they're gonna be less willing to raise new queens. So you want to grab about 8 to 10 frames of capped brood or uncapped brood with young nurse bees and shake them directly into this box. You want to make sure that the queen's not going in this box. So you want to make sure you find the queen or make sure the queen's not being shaken to the box. And shake somewhere between 8 to 10 frames in here. And then you seal it up for about 1 to 2 hours in a cool, dark place. You don't want to leave this in the middle of the sun because it can overheat and the bees are unable to move out. The ventilation at the bottom really helps. But you can move it inside if you want to. You can move it. Sometimes I move it kind of under trees, for example, so it has some really good shading. But it's really important to keep it cool and dark so the bees don't overheat. And the sponges do help. That's one reason I put kind of wet sponges at the bottom to help with some of that. But it's so important having a cool, dark place. After 1 to 2 hours in here, you can put your grafting cells directly in here and you keep them in this warm box for about 24 hours. Now, the reason you're putting this in here for only 24 hours is you use these as your cell starters. And so they're in this forming behavior, they start drawing out the cells, and you get those cells started. And after that, you move those into a finisher colony. Now, one thing I really like about the swarm box is there's not a lot of prep. So what that means is basically you can just decide to raise a queen one day and you can start grafting 2 hours, 1 to 2 hours later. So it's a really quick method. What's great about Swarmbox too is you can raise a large amount of queens. So, I've raised hundreds of queens at one time in here. So you can raise probably 60 or 80 queens at a time, even more than that inside the swarm boxes. And so it's a really, really great way to raise large amounts of queens. Now, I've seen beekeepers do modified swarm boxes. And so instead of having the swarm box or shaker box, for example, people can modify just a deep box, for example, and kind of close those off for 24 hours before opening up to the rest of the colony. And I'll talk about that a little bit in some of these other methods, but there's a lot of different ways to do swarm box. And I think a lot of commercial beekeepers utilize the swarm box because it allows them to raise large amounts of queen, but also really great queens. Okay, so after 24 hours, you have your cell started, your queen cell started, and now you have to move into a strong finisher colony to finish those cells and cap those queen cells. So one thing I typically do is I move them to a queen right finisher colony. And so this has to be prepared about 9 days before grafting. And so this requires a little bit of time. So you have a separate starter, which is swarm box, and then you have your finisher colony. And so you want to prepare this finisher colony about 9 days beforehand. So this does require a little bit of prep. But having a really strong um, finisher colony will allow you to finish drawing out all the cells and have the highest quality queens as possible because these finisher colonies will be feeding the queens, taking care of them, and raising them. So if you have a really small finisher colony and you don't have a lot of bees or a lot of nutrients, that could lead to either some of those cells being uncapped or it could lead to some queen issues downstream. So I typically prefer a minimum of 9 to 10 days before for grafting. And if you already have a strong colony, you don't have to worry about modifying this at all. But if you don't have a strong colony, you may have to do some combining and form a large colony. So the colony will finish raising the cells after the swarm box has started them, and the finisher colony should always be on the verge of swarming, right? And so it should have a lot of bees, and so you might have to shake nurse bees from other colonies into this. And so it's almost like if you look at the top of the box, the bees are almost covering the top of the frames. Because if you can just look down them and you see the top of the top bar, that could be a good sign that you don't have enough bees in your box because you need a lot of bees, a lot of young bees that are willing to raise a lot of queens. Now, the finisher kind of depends on how many queens you're raising. And so this is a situation where I'm raising, about 80 to 100 queens, right? So I need a really strong finisher. But if you're only raising maybe 10 or 20 queens, you may need a smaller finisher. So the reason you may want a stronger finisher is based on how many queens you want them to raise and finish. And then typically what you can do is you can move some of the young larvae and caproot to the top of the box separated by a queen excluder. So you want those bees to kind of move up and down. So what I typically do is I'll move kind of young eggs and larvae kind of surrounding the queen cells, about 3 frames if possible, just so you have some young bees. I also add some kind of older larvae and cap larvae, so those young nurse bees are emerging and are going to take care of the queen cells. They always add a few frames of honey and pollen. You can also feed them if possible. So if you don't have frames, you can add a frame feeder or feed them to make sure they have the nutrients and the sugar to finish drawing out those cells because nutrients are really important for this part. And one thing you might want to do is kind of rotate your frame. So adding, cap brood into the top box. So you constantly have young nurse bees that aren't exposed to the queen that are willing to help dry out these queen cells. One thing you can do is as a cell builder, instead of having a swarm box or shaker box, you can have a queenless cell builder. And so instead of utilizing the swarming behavior for raising new queens, you can have this utilize this sort of queenless behavior to raise new queens. So if you just have one colony, and let's say you have a double deep colony, maybe two deeps and a medium, it's a really strong colony, you can shake all those bees down into a single box because you want this colony to basically be on the verge of swarming. You want this to be full, like almost like the bees are bearding in the front, a lot of bees on the tops. They're kind of in that verge of swarming. You also want to remove that queen. So what you can do is maybe make a four frame nook or maybe make a colony, move some brood and bees to the colony with the old queen, and then shake the rest of the bees to the bottom. There are some situations we can take bees from other colonies and shake them in here, like young nurse bees, but you want to make sure that this is almost on the verge of swarming because the cell builder is really important. You want to really have a strong cell builder. Because if you don't, and this is something you'll notice as you begin grafting, if your cell builder is not strong enough, it may not draw out all the cells. But like I said, it really depends on how many cells you're raising. So if you're only raising a few cells, like you're grafting maybe, 10, for example, you can have a smaller queenless cell builder. But if you're raising, 40 or 60, which is probably the maximum for this, you might want to, you'll definitely have to have a stronger cell builder. So yeah, like I said, add nurse bees until all frames are fully covered and almost like they're on top. You might see a little bit bearding on the front, and that's a good sign. But you want to make sure the queen's not in this colony so it's queenless. You want to leave this queenless for at least 24 hours later so they're changing behaviors and they're in that queen rearing mode. After 24 hours later, you can put your grafts directly in here. Like I said, you can probably put somewhere between 40 to 60 if you want to. If you're raising less, maybe 10 or so. You always want to raise a little bit extra for your first time because some won't take. So what you can do is basically you can have the same finisher colony. And so like I mentioned with the swarm box and putting onto a finisher colony, you can move this queenless colony directly on top of the finisher colony. And so this is definitely one method. So after 24 hours later, after you get started, moving it to a finisher colony, and that allows the strong finisher colony to fill it out. With this, you want to make sure you're adding a lot of new cap brood into this top box. You have these young bees emerging and going to take care of the queen cells. But this is definitely one way to finish your colonies. But you definitely don't have to move it to a finisher colony. So one thing that's great about a queenless colony is you can use that as your cell builder, your starter, and then your finisher colony. So you have the option of moving it and moving the frames over to a finisher colony, or you have the option of keeping it inside the queenless colony. So in a situation like this, if you're moving the queen cells over, this situation where you might want this queenless colony to raise more queens. Now, in most situations, you're not raising many queens. It probably makes sense to have a queenless starter and finisher, right? Because if you're only raising, 10 or 20 or maybe even less than that, it may just make sense to have a queenless colony because after you raise your queen cells and move those over into either four frame nooks, your splits, or other colonies, you can keep a queen cell in this finisher colony and they'll raise that queen and replace that queen. So a starter finisher is a really good method for a lot of new beekeepers. Now, this is a really great method for just a smaller number of queen cells, so about 10. So one reason that you may not be able to finish more cells is because the colony is not strong enough, doesn't have enough resources to fully finish large amounts of cells. So if you're raising 40 to 60, you might want to finish these cells on a larger colony that have a lot more bees and a lot more resources. But if you're only raising 10, this could be a really great way to start and finish the colonies. So basically, exact same thing. Removing the queen, adding extra nurse bees so the frames are fully covered, almost like they're on the verge of swarming. After 24 hours later, you can put your grafts in there, and then you can leave them in there until they're around a certain age, where you can either put them to incubator, put them in four frame nooks, and then keep one queen cell in here so you can replace that queen. But you definitely want to make sure the check the colony for queen cells. So if a queen does emerge early, they don't go back and kill any of the queens. One method I'll talk about, and I think this is really practical for a lot of small scale beekeepers, is the cloak board method. Something that a lot of beekeepers use, and it's a really practical method for a lot of small scale beekeepers. With any of these, you want to make sure you have a strong, healthy, well-fed colony with a young queen. And you want to set up the cell builder by having this cloak board. Now, this cloak board basically has a queen excluder and then has this metal sheet that goes in here. And it's sort of a cloak, right? Because you're basically hiding the alarm pheromones, or not the alarm pheromones, the queen pheromone from the bottom. And so you're basically forcing the bees on the top to be cloaked and not be basically exposed to the scent of the queen. And so it allows you to basically form a temporary queenless colony or kind of a swarming colony to produce these queens, and they can open it up and turn it into a finisher colony. So it allows you to have a starter and finisher on the same method. And I'll walk you through each one. So let's say you have a really strong colony, so two double deeps, it has a lot of bees. You may want to add more bees to it to make it as strong as possible. But let's say you have a double deep, for example. And what you want to do is basically a queen excluder and put the queen at the bottom. So you want to find the queen because you want to make sure you know where the queen is and make sure the queen's at the bottom. Now let's say the entrance is this way. So you can see these little bees kind of moving out this entrance. So this is how you kind of start in your colony, and maybe you choose this one as your strong colony with a young queen to raise queens or raise future queens. Next, what you do is you basically switch the boxes. So instead of the entrance being this direction, you basically move the box 180 so the entrance is facing the other direction. And then you close the entrance on this bottom box. So you basically rotate this 180 and closing the entrance. Then you add the cloak board and you add this top box on top. Now, one thing about Cloakboard is you can move the entrance. So this is where the entrance would be. You want the entrance to be the opposite direction, but you want this to be open so these bees can actually move in and out. And you want to make sure this cloakboard is fully shut. So you want to make sure you have that cloakboard all the way on. Now, as top box, you want to make sure you have frames of brood, not only young brood, but also cap brood. But you also want to make sure you have frames of honey and pollen to support the cell building. So this is something you want to prepare probably days before grafting. I've seen people do this a couple hours to 24 hours beforehand. I've seen people like prepare this, 4 days beforehand. But I would say that if you do this a couple hours beforehand, you should be good to start grafting. But probably at least a few days if possible. About the day before grafting, you open up this entrance. So now you have the queen red colony at the bottom. The entrance is open, so the bees are actually able to move in and out. They're also able to kind of forage for nutrients. And then the top one, this one's still closed off. And you have the cloak board, so it's the scent's hidden from the bottom to the top. So after this colony is basically queenless, and they're in that kind of high behavior to raise large amounts of queen, especially this is really strong. And you may want to add more bees if this top box isn't strong enough. Now, I guess you're probably wondering like why do you move this entrance? I guess one thing you want to do is you want to make sure these bees in the top box aren't flying to the entrance. And so one way we do this by reversing the entrance. But even if you don't close this entrance, some of these top bees will still be trained to go to the bottom box. So one reason that we close this bottom entrance so those bees on top box don't fly in. And so it's one of the reasons we close it because you want to make sure these bees get trained to use this new entrance but also be trained to stay in the same box. That's one reason we rotate it and close the entrance for a little bit. And then next, so on your actual grafting day, so the day before grafting, right, you're preparing everything. You have the entrances open. The bees are already trained to go to their new entrances. The top box is really strong, queenless, and ready to make a lot of queens. Like I said, you want it to be almost swarmy. So if you have to, what's great about this method is you can add brood from the bottom and bees from the bottom and move it to the top if possible. After that, you can graft your queen cells, place it into the top box, which is fully closed. You have that cloak board and allows them to start the cells. So it's very similar to kind of the queenless starter, but instead of having on a separate box, you have them combined with this queen red colony. About 2 days later, you can actually remove the slide and turn this to a queen excluder. So you're shifting this from your starter colony to a finisher colony. So now you have this colony all combined. The workers from the bottom are able to move up and finish that colony and take care of it and raise your cells. So I've seen people maintain this for multiple months. What's great about this is you basically have your brood production system at the bottom, and so over time you can move that brood up, and constantly move brood all the way up to the top. And so you have all this kind of brood production at the bottom. You can move that up so you make sure you have young bees always in that top box. So it allows you to raise a lot of queens over time. I'd probably recommend raising no more than 40 to 60 queens at a time. But every 4 days after your graft, once the cells are capped, you can move those queen cells into an incubator temporarily. You can move them into nooks, for example, mating nooks, and you can consistently raise queens throughout the year. And so obviously people you do this and raise 6 to 7,000 queen cells per year if you have everything timed right, you have the incubator set up and things like that. So it'd be a really great way to raise large amounts of queen. One thing I also like about this is one thing you can do is basically shift this into sort of a cell bank. So you can keep the cells in here. So let's say you're raising 40 to 60 cells, and once they're capped, you can incubate these cells until you're ready to transport them into a four-frame nook or a new split. One thing you can also do is you can basically use it as a split and move this colony and keep a queen cell in there so they raise a new queen. So it could be a good way to not only raise queens, but then also make a future split if that's sort of your goal. One thing that's good about the cloakboard method also is you can use it as a mated queen bank. So there may be some situations where you're biting mated queens, but your colonies aren't ready for you to put the mated queens into the colonies. Or maybe you have mating nooks, for example, so you're mating your queens and you're storing them temporarily to either sell to a beekeeper or put into your colonies. So you can convert this kind of cloakboard colony into a mated queen bank. But in that situation, you want to make sure that the cloakboard's closed and so basically, this becomes a queenless colony. This becomes a queen red colony, and that allows them to take care of the mated queens. You want to make sure this is queenless for at least 24 hours before you introduce the mated queens. And you always want to make sure there's enough nutrients at the top. You want to make sure there's a lot of young brood and then cap brood. So those bees are emerging and are going to take care of the bees. So cap brood is going to be really important because you want a lot of those young nurse bees in the top box to take care of the mated queens. Because as the bees get older, they're gonna be less willing to take care of the mated queens because they get grumpier. They're like, well, why do I have to raise queens now? So you definitely want a lot of young nurse bees when having a queen bank. Okay, so once you have the queen cells, right, what do you do now? So I mean, either you're making your splits, you're making your four frame nooks, you can put those queen cells directly into your queenless mating nook or queenless colony or nook, or you can make specific mating nooks, which are smaller colonies where you put the queen cells into, the queen's mate, and then you can put them into either a queen bank or sell the mated queens or put the mated queens into a colony. Now, most situations, I don't know why you'd use a mating nook unless you're a large scale queen producer and you're selling mated queens. So I'd say for most situations, there's no need for you to have a mating nook. But most situations, you're probably moving those queen cells into either queenless colony, like a split, or a four-frame nook. But these are the different kind of mating nooks you can use if you do plan on producing mated queens, selling mated queens, and things like that. So this is what a mini mating nooks looks like. It's like a styrofoam box with these mini frames. So the problem with this is you do need extra equipment and you have to get these frames drawn out. So these can be kind of a pain and takes a while to get started. But these are a really great way for mating the queens, capturing the mated queens, and then putting them into a queen bank or selling those mated queens. And so you can basically maintain these mating nooks, consistently put queens in there for them to mate, and then move them and sell them later. I think what a lot of beekeepers do is they modify their deep boxes and move them to sections. So they're basically two frame boxes. So you can add these kind of plywood dividers. And this picture is a little different, but I usually have like one entrance right here on this side. The middle one would be entrance on the other side, and then this entrance would be on the same side, so not as much drift. But you can put about two frames in here of cap brood, introduce your queen cells, and so your queens are allowed to fly out and mate. You can also make or even buy single two-frame mating nooks, so this is a really great method also. One thing that's great about these two is you don't have to buy and start extra equipment. So with this, these frames are smaller and it requires different equipment for it. With these two-frame mating nooks that are multiple in one deep box or a single two-frame mating nook is you can use the same deep frames for your mating nooks. But also, if you just have a four-frame nook and you plan on raising those, or if you have your split, you can move those queen cells directly into those queenless colonies or those four-frame nooks. So it just kind of depends on what your goals are and why you're raising queens. So are you raising queens just for yourself or are you raising queens for other people? Okay, so next we'll get into the actual grafting part. So this is sort of the really the grafting schedule. Not only when the grafting, but also when you should be evaluating and checking the queens and seeing how well they mated and whether they're still in the colony. So day one is when your breeder colony. So let's say you select your breeder colony. This is when your queens begin laying eggs. After 3 days, the eggs will hatch. And then around day four, this is when you want to graft your larva. So if you plan on caging your queen, for example, what I typically do is I'll cage her on a Monday. And on Monday, it'll take her about 12 hours to start laying eggs. And then I'll come back on a Friday when the larvae are just hatched and probably less than 12 hours old and graft based on that. And so if you're not sure about the right age, and as you gain experience about identifying the right age, you can use that method on a Monday and a Friday. So caging the queen on a Monday, grafting on a Friday, so you kind of get a feel for the age of the grafts and the larva. And so once you graft, you place into a cell builder right away. So, you can place them into a swarm or shaker box cell builder, a queenless cell builder, or your cloakboard cell builder. After day five, you move your grafts to your finisher colony. So you typically keep in the cell builder from 1 day, and then you move your grafts after the cells are built to a finisher colony to finish out the cells. And then about day 8 or 9, the queen cells are fully sealed, and then you have a lot of flexibility depending on what your goals are. Now, you at the stage at 8 or 9, you have a few different methods, right? You can either keep the queen cells, in the colony, in the finisher colony. You can move them to an incubator, or you can move them into your nook or your mating nook. Now, I typically wouldn't move them right away at day 9 because they're still kind of pre-pupa stage, so they're still spinning cocoon and going through metamorphosis. I probably wouldn't move them until around day 12 or so. I mean, day 10 or 12. So once they become pupa, that's a good time to move the cells over because they're very sensitive around day 8 or 9, even if they are sealed. And then you want the adult queens will emerge around day 16. Then you want to make sure that you move the cells before that because sometimes queens will emerge earlier. And if a queen emerges earlier, they can go back and kill the rest of your queen cells. So it's really important to move them earlier if possible. I mean, at least by day 14. Around day 21, so about 5 to 7 days after the queen emerges, she'll go on her mating flights. And so these mating flights can last maybe a few days to a week. And then you want to look back around day 30. So look for your mated queens that are laying eggs. But I mean, one, you want to make sure the queen's still in the colony. So do your checkbacks, but make sure she's starting to lay eggs. And then a few days later, you can kind of evaluate the brood pattern and see how well she's doing. So this is kind of really the time frame of when you're raising queens. So one thing a lot of bee supply stores is have this dial, so it kind of helps you keep track of everything. So right here, this is when the eggs first laid. So this green is when the egg stages, it hatches around day 4. So that's when we want to graft from them. And then you have, this is basically your cell builder, and then you have sort of your finisher colony. So when the cell's capped. So yeah, right around here. I mean, like I said, the cells starting to be capped around age 8 and age 9, and then around age 10 to 12, right? This is when you don't want to mess with your queen cells too much at all because they can still be really sensitive. Then right here it says transfer. So this is a good time to transfer your queens. You might transfer your queens earlier if you want around age 12, but it's always best to wait a little bit longer if possible. But it kind of depends on your preference. So you can either transfer into a Nook or you can transfer into an incubator, have them emerge in them, um, and so on. So I've seen people put them in incubator around age 10, so that's definitely fine also. And so you have an incubator, you can buy a lot of different incubators, make sure it's at about 95 degrees, 35 C. That's a good way to keep that temperature and raise an incubator. So step one is one thing you can do as a beekeeper, especially if you're not aware of the right ages of larvae, because they can be really small, and some beekeepers might not know what the right age larva is, because it's really important to get the right age when you're doing your grafting. So one thing you can purchase is a deep isolation frame. So this is it's a metal basically containment system with queen excluded on the side. So that allows the workers to go in and out, but you cage the queen inside here so the queen's confined in here. So you put the frame in, you put the queen, and you cage the queen in here. And so after, I mean, probably within a few hours, sometimes it takes a little bit longer, the queen will begin laying eggs. and you know exactly which age they are. So if you're caging the queen on a Monday, you know the queen's gonna be laying somewhere between the next 24 hours. Another method is a Genter box. It's also called like a Nicolette box, but a lot of bee supply stores have these. Sort of the same method, but it's a smaller containment system. So instead of an entire frame, you have this system, and you cage the queen in here for 24 hours later, and she starts laying eggs. But on the bottom of these, you have these basically small like Lego type pieces that you can pull out. And so once the larvae are at age, you can basically pull out these Lego pieces and add them to a cell bar. And so if you aren't because if you don't want to graft or you have issues with grafting, this could be one easy way to move the larva over to your starter colony without actually grafting. And I will say with both these, sometimes it takes a little bit longer for the queen to start laying eggs, right? So sometimes if you check right away after you cage a queen, she'll be kind of running and get acclimated to the queen confinement cage, either deep isolation or Genter box. And so you might not see eggs until about 12 hours afterwards. But sometimes the queen might start laying eggs right away, especially if your frame has been in the colony for a while, the workers had a chance to clean up the cells and take care of them. So sometimes what I'll typically, I guess you could do is you could add your frame you want the queen to lay on, put in the colony 24 hours later beforehand, and have them lay in it. But the problem with that sometimes is if you have a really heavy honey flow, they can start putting nectar directly into that frame, and so that can be kind of problematic also. The next step is actually grafting. So you can basically make your own bee grafting station. So you can buy these at bee supply stores. I think they're around, $40 to $60. There's some 3D printed versions you can buy that are smaller. And so there's a lot of different ways you can do a grafting station. There's some that you can attach to your steering wheel to graft in your car. But you can even set this up next, like against a box, for example. You want to tilt the frame slightly onto your grafting station. And you also want to have a sort of a dark area with a light that allows you to see the larva and graft from them because it can be kind of hard to see the larva, especially if you don't have great eye vision. And so having a really great light and direct light can be really helpful. So you can use kind of a headlamp if you want. You can use a handheld light, or you can have one of those reading magnifying lights next to it, and that can be really effective. So you want to set it right here, and you want to try to graft as soon as possible. So probably graft within a couple hours because you don't want that larva to dry out and cause any issues. Typically, you want to graft at least at room temperature. If it can be warmer in there, that can be really helpful, but you want it to be at least at room temperature. If it's colder, that could cause issue with the larva and cause other issues. So these are two different types of grafting tools you can use. One thing that's commonly used is the Chinese grafting tool. This has this basically spring-loaded device that allows you to kind of push that insert in and out. It has a plunger at the bottom that allows you to go into the cells, move up the larva, and then graft them into your cells. And so I always recommend this to a lot of new beekeepers. For me, once you get good at it, it's pretty easy. Each tool is a little different. So when you buy them, you'll buy it as a whole bag of them. And some of them work really well and some other don't work as well. And you'll notice that once you start grafting. And one thing I always recommend is if you have a grafting tool that you like, don't share with anybody else because you don't want to lose it or you want them to ruin it at all. The German grafting tool is just sort of a metal, kind of a toothpick, for example. And so instead of using that plunger to go in, move up the jelly and the larva, you basically use this toothpick to pick up the larva. So this is also known as dry grafting. So with the Chinese grafting tool, you're moving up not only the real jelly and the larva, so you're moving both at the same time. So you're not really touching the larva and you're moving them under that jelly, for example. So this really eliminates a lot of your risk for damaging the larva. Whereas the German grafting tool is kind of a dry graft where you're not picking up the jelly, you're just picking up the larva directly. So does require a little bit more skill because if you're not proficient at it and not good at it, then you could actually damage the larva. But yeah, both these are pretty cheap, and so you can kind of buy both and use both and see which one works best for you. Next, you'll need are grafting, so cell bars and frames. And so this is what a cell bar looks like, and it can typically hold 3 bars on them. You can fit somewhere between 10 or 15 cells in each. And so if you put 15 full cells in here, you can fit about 45 cells in one. And so, if you're grafting in some of these cell builders, 45 is probably the capacity. So you might want to do one of these with only 45 at the max. You can use JZ cells, these plastic cells that insert right in here. So you're grafting basically larvae directly into these cells, and then they basically poke into the cell bars. And so that's one great way to graft into these and move them over. There's a lot of different ways to make these. So I've seen beekeepers make wooden dowels, make kind of wax cells. I've seen people use acorns. So you can use small acorns and use those as your cells. I probably recommend the JZ cells. That's a good method. I mean, I get a lot of questions about the color. The color doesn't matter at all. It could be a good way for you to track your different stocks. And so let's say you're grafting from multiple colonies and you keep one colony black, one colony blue, one colony green. And it can be really great and effective way for you to track, where your grafts are coming from. So, but other than that, the color doesn't matter at all. So this is what the method kind of looks like, right? So this is a Chinese grafting tool. So it has this wooden dowel right here, and it has kind of this tongue, for example. This tongue is very flexible. So as you go in, it allows it to scoop under the jelly and under the larva and move it up. Now this is spring loaded, so as you put this into cell, you can push this wooden dowel down, and that pushes the larva and the jelly directly into the cell. So you're basically scooping underneath the jelly and the larva, and then you place that into the cells and use that wooden dowel to push that larva and jelly back into the cells. So once you get really quick at it, I mean, you can raise thousands and thousands of queens per day, especially you have a frame, has a bunch of young larvae, and once you get really good at it, it can be really quick. But you definitely want to choose larva that's young, ideally less than 24 hours, because the younger the larva, the higher quality the queen's going to be, and the more likely the starter colony is to start those queen cells. Now, if you're doing queen confinement, you can basically control the age of the larva so you know they're at least less than 24 hours. But 12 hours is ideal. You get best queens that way. Proper lighting is really important, and so I typically when I do my queen rearing classes is have a headlamp or a magnifying glass to make it easier for people to find them. You can use a handheld lamp if you want to, but well-lit areas is really important. So I typically keep it dark and then add a light to help find these larvae. Um, and then typically you want to keep it to about 75 degrees Fahrenheit with humidity around 50% if possible to prevent any larvae from drying out. I've grafted in all different situations, so, as long as you're pretty fast at grafting, the temperature doesn't matter too much, but ideally you want the temperature to be at least above 75 degrees, because you want the larva to dry out. Sometimes if it takes you a lot longer to graft, you can get a wet towel and put it over the larva, and that keeps them moist and keeps them from drying out. And sometimes you see the issues, especially when so this larva, for example, you can see there's a big pool of jelly. And so this one's really well fed. So like for me, I wouldn't see any issue with this. But sometimes when there's a pollen dearth, there's not a lot of nectar in here, these larvae may not have a big pool of jelly. And so that's when you start getting the drying situations. And so if possible, I try to find a frame that has larvae in this big pool of jelly because that's gonna be better for you. And they always want to make sure you clean and sanitize your grafting tools. So whether you're doing your Chinese grafting tools or your German grafting tools, you want to make sure they're sanitized so you're not spreading diseases between and within colonies. So one thing with grafting is really important to understand cast termination. So I talked about this, I think during our first or second week, but you definitely want to have larvae really young because at some point there's no way that queen can be on that queen trajectory. But also if you're grafting over older larvae, they could be smaller, less developed queens. And so one thing we always view queens and workers as is that they're clear casts, right? There's a clear queen and clear workers. But if you're grafting larvae that's too old, you could have the potential to have these intercasts. So queens that are smaller and may have more worker-like features because there's a whole gradient between workers and queens. I always like to call workers basically starved queens. And so you want to make sure you graft larvae as young as possible so you produce the highest quality queens as possible, the bigger queens, the queens with the bigger ovaries, and so on. And so it's really important to choose the right grafting age. Okay, so once you graft and once you put in the cells, you put them into the cell builder. So like I mentioned earlier on, we have different cell building methods. And this is what it looks like 24 hours after your cell builder. So as you can see, there's there's not a lot of acceptance, right, in this frame. So this was a new beekeeper that started grafting. As you can see, like this cell was starting to be built, and you look inside this, there's still larvae in here, so this is a good sign that this cell's being built. We see some of these, you can see that they don't have the wax kind of around them, and these cells haven't been built quite yet. And if you actually look deeply in here, you'll notice that there's no larva left in there because those have been removed. And so for this, this is a good sign that maybe there's some issue with your cell starter because you only have one or two, one, two, three, four, five, six, maybe out of 20 that were accepted after cell builder. And so if you have a situation like this, you probably don't have enough bees in your cell builder. Maybe you had too old of bees, so you have enough nurse bees, or maybe you have the right nutrients to support the cell building process. And so, if you have grafts like this right away, it may be an issue with the grafting, but could also be an issue with the cell builder. And then once you place it into a finisher colony, they'll finish the cells and finish capping them up. And so this is what the cells will look like. And as you see, they did a really great job of getting their cell starters. You can see that there's not many open spots. There's a few here or there, but overall their acceptance was pretty dang high. So these are fully capped, and these are probably at the right age to either move to an incubator or move to potentially a nook or a queenless colony or queenless split. So one option you have is incubators. So you can buy a queen cell incubator. I mean, you can definitely buy a lot of different types of incubators. I think Man Lake sells like chicken incubators, and so as long as you get the temperature right, and if you could control humidity, that's even better. But you can buy some cheap incubators. I've seen people make their own incubators out of refrigerators, so there's a lot of different ways you can make an incubator. So if you do plan on raising large amounts of queens and want to store them temporarily into an incubator, that could be a good thing to have. There's also queen cell transportation incubators. So let's say you're moving queen cells to different beekeepers. So I mean, let's say you're in Texas and you have yards that are pretty far apart. You want to make sure you keep those queen cells as healthy and a well environmentally controlled area as possible. So if you move in them multiple hours, you may want to have a queen cell transportation system. Or if you're selling queen cells to other beekeepers, this could be really useful method. And so I mentioned this beforehand, but once you have your queen cells, so right when they're about to emerge from your incubator or from the cell bank, you can move them to a mating nook to produce mated queens. So this is probably the case for most beekeepers in this room, for most small scale beekeepers. You probably have no reason to have a separate mating nook. I mean, you might, but in most cases, you're probably putting those queen cells directly into a queenless split or directly into a four frame nook. But there may be a situation where you are a producer and you might sell mated queens for some reason. And these are ways that you can mate the queens and then sell mated queens once you identify a good brood pattern. So you can do the mini mating nooks. So putting the queens into these mini mating nooks and mate them that way. You can modify a deep into three sections, and these are basically two frame mating nooks. So you mate the queen that way, and then once the queen starts laying eggs and see a brood pattern, you can catch that queen and then ship them for selling or sell them to a local beekeeper, or you can have an individual single two frame mating nook. One thing you can do is so if you do have mated queens, you can introduce them in queen introduction cages. Obviously, this is more the case if you're introducing a queen into a foreign colony. So let's say you're introducing a virgin queen or you're introducing a mated queen from either yourself or another beekeeper. You can do different introduction cages. But most cases, you put the queen cell directly into that queenless colony that's been queenless for 24 hours later. So those workers will be willing to accept that queen. It should be accepted in the colony. So you don't have really a case for using the introduction cages. But you can use kind of roller cages or different cages for the virgin queen cells. So the queen cell is not damaged or the colony isn't going to tear down that queen cell. So this is more for mated queens, but there's different things you can do to cage the queen cell. So once she's emerged, you can basically release her back into the colony. One optional thing is queen marking pens. So you mark queens different ways depending on your goals. So there's different colors you can purchase from any bee supply store, but even like paint pens that you buy from like a Lowe's or Home Depot, those can work really well. You want to make sure they're definitely not toxic. So, use like a acrylic, I believe, is commonly used. Um, But yeah, you can definitely buy these from a bee supply store, but even like a Home Depot or some kind of modeling store. But you can get them in different colors. You can also use like the tester paints. So if you don't like these colors, you might use kind of different colors. You can use the tester paints and use kind of a Q-tip or like a toothpick, for example, to mark the queens. But this is probably the easiest way to buy some of these marking pens and mark the queen. It's also good to know. It also allows you to track the queen and see how well the queen's doing and see if she's been replaced or not. One thing you do also is these queen marking discs. So you can buy these at also many bee supply store. They have a bunch of different numbers. Sometimes they're color coded, and you can glue these on the back of the bee. You can use like a simple wood glue, but there's also resin-based glues you can use to glue it back to the bee. And so if you're doing a queen breeding program and you want to track each queen individually, this could be a good method because if you're marking a bunch of queens green color, it's hard to distinguish them. But if they have specific color and number, it's to make it easier for you to track those queens. So there's some considerations with your mating yards, right? So queens are just one half the equation. So, if you're raising queens, the drone part of it is something you probably need to consider. So, isolation is probably the best way, right? Because you're isolating your colonies, and maybe you have a few colonies, and their only role is to produce drones. So a lot of beekeepers, they may have maybe 10 drone producing colonies per 100 colonies, and these colonies, their only role is to produce large amounts of drones and how they fertile drones before you start grafting. So typically, what they do is they start raising drones about 40 days before grafting. By the time those 40 days are up, those drones are sexually mature and are able to mate with their queen. And if they're isolated, they know that their drones are going to their DCAs and are going to mate with their queens. Now, isolation is really hard and really difficult and probably impossible for a lot of areas in Texas. But if you are in an isolated area, so maybe you're in a forest, maybe there's only feral colonies around, or you own the King Ranch, for example, or a large ranch area that's pretty long, then you could be in a pretty isolated area. And that kind of eliminates you from having to do insemination and some other closed breeding. So like I said, having abundant drone source is really important. And so that's one thing to also consider when grafting. So if you're grafting in Valentine's Day or middle February, just know that if you're grafting then that the drones probably aren't ready and there's not going to be a lot of drones available for your mating. Now, it's not to say that there won't be drones available and your queen's not going to mate, but she's not going to mate with as many drones that are producing higher amounts of sperm. And so when you're grafting, it might be worthwhile to wait until probably right around now into early April to start grafting because right around now there's a lot of drones. You can probably see that in your colony that they're producing a lot of drones, and probably about now they're probably mature and they're pretty high quality. Favorable environments. So one thing with mating is choosing the best environment. But sometimes you can't control the environment, right? As much as you want to control the rain, the wind, and the environment, there's not much we can do. And so, it's hard to predict what's going to look like in, 21 days. But just know that if your queens are going their mating flights during rainy conditions, it's really windy and the weather's really poor, that the queen may mate with less drones and the mating quality may be really low but also diverse pollen forage availability. So one thing that's great about Texas is there's a lot of pollen resources. There's a lot of nutrients available, especially here in the spring. And so right around now, there's enough pollen and nutrients to support the colony. But let's say in your situation where you're raising queens at different times of year, you're in an area where there's not a lot of pollen or nectar coming into the colony, you may want to supplement your colony to provide them enough nutrients. But regardless, you want to do that for your cell building and your finisher colony because you want to make sure they have enough food as possible to take care of those queens, and raise high quality queens. Okay, perfect. So I think we'll take a 10-minute break. So we'll come back at 10:30 and then we'll get into the second part. We'll talk about queen breeding, insemination, and how to run your own breeding program.